Shall I start? Shall I start?
Yes, sir. Start, sir.
Okay. Okay. What is sigma AB? What is sigma AB? Can you tell me what is sigma AB? Yes, please.
Sir, 318.
318 sigma. Sorry. Sigma. Sigma AB. 318.31. What is the unit?
7.
Okay, unit.
318.47. Unit will be
Newton
per meter.
Newton per meter square.
mm, not meter square, mm square. Load in Newton. Area of cross section in mm square. Newton per mm square. Sigma BC.
407.43.
407.
407.437. In the other way I can express this Newton per mm square. MPa. 1 Newton per mm square is equal to 1 MPa. Sigma CD.
159.15.
sir.
159.15
15.
Newton per
mm square.
mm square or MPa. So what is the sign of this sigma BC? I have not taken this negative square. What is the sign of sigma BC? PBC is minus 200 kilonewton.
Minus.
Yes,
Negative.
minus 407. Sorry. Minus 407 point this, or this is under, I can write 407.43 MPa. These are compressive stress. This is compressive stress. Okay, this is compressive stress. Oh, this is fine. Okay. Next, we need to also find the deformation. I will leave it to you. After calculating so many problems, you should be able to find the same. DL is equal to PL by DL total is equal to PL by AEAB, PL by AEBC, PL by AECD. Take that summation, we will get deformation total. Okay, I'll move ahead to the next type of problems. Okay. Okay. Or before that, okay, we'll club all this and we'll solve before. Okay, we get confused. So where it is, where it is. Okay, the problem definition is like this. Before that, I'll write the sketch of the problem and come to know. This is a combination of sections. Until now we have discussed about the section, the uniform cross section Now we are going to discuss the problem with the bar with the taper cross section along with the uniform cross section. This is called a stepped bars, and there is a uneven steps. Okay. For example, yeah, as soon as you see a taper like this, it means that it is tapering like this. It is a tapered bar. You will mention that in case if it gives dia, it means that it is a circular bar, and then we should use the formula related to circular bar. Okay. Not written neatly, don't worry. This is aluminum. This is steel. This is also steel. Okay. This is of length 600 mm. This is of length, steel part is of 700 mm. And the second steel part is of 500 mm. Load 4P is acting towards left hand side. Right in other color. Four P, 2P, P, 3P. So, and he has given dia Young's modulus of aluminum is 70 GPa. As soon as you use GPa, write in GPa, convert into Newton per mm square. 70 into 10 power 3 Newton per mm square. Young's modulus of steel, which is equal to 200 GPa, 200 GPa, 200 GPa, 200 into 10 power 3 Newton per mm square. Big end diameter and small end diameter 40 mm, 12.5 mm. Big end is 40, dia 40. Small end is dia 12.5 mm, 12.5 mm. Okay. Determine the magnitude of force P. What is the magnitude of force P? Such that the net deformation in the bar does not exceed 1 mm. Deformation total will not exceed 1 mm. That is equal to 1 mm. Maximum it can be 1 mm. Okay, this is the problem statement. So in the difference between the previous problem and this problem is the previous problem what we have discussed, those problems were of uniform cross section, whereas this problem is of varying cross section. You can see that tapering circular rod, this aluminum part is a tapering circular rod. Okay, we'll go ahead and solve the problem. Everything remains the same, finding the forces. Only the formula regarding the deformation, when it comes, it will change. Okay, let us go ahead and solve the problem. I'll take this section. XX. Okay. P of AB, summation of forces in x direction is equal to 0. P of AB is equal to P kilonewton. Next, P, BC, 4P, 2P, summation of forces in x direction is equal to 0, minus 4P plus 2P plus PBC is equal to 0, or PBC is equal to 2P. Section here. XX, I have already taken section here, and this is this part, XX.
Sir,
Yes.
sir, in first diagram it should come 4P.
P of A. Oh, sorry. Thank you. This is 4P. This is 2P. This is P. This is PCD. Okay, away from the cross section, we should neglect those forces. Only the equilibrium will be taken. This PCD will balance only the force acting towards left hand side. The total internal forces will be, and the total resultant force PCD will be only due to the forces towards its left hand side. Okay, and right, summation of forces in x direction is equal to 0, minus 4P plus 2P minus P minus plus 2P minus P plus PCD is equal to 0, or PCD, which is equal to minus 4P plus 2P minus P, okay, minus 4P minus 5P, 3P, right? PCD is equal to 3P, PBC is equal to 2P, PAB is equal to 4P kilonewton. If you want to write kilonewton, you can write. Finally, whatever answer you get, you express in 10 power 3. That is kilonewton. Okay, 3P. Okay, we'll go ahead. Deformation total is equal to deformation in aluminum plus deformation in steel plus deformation in steel. Okay, which is equal to 1 mm maximum deformation P L by AE of aluminum plus P L by AE of steel plus P L by AE of steel part 1, I'll write, of steel part 1, PL by AE, sorry, steel part 2, steel part 2, PL by AE, steel part 3, which is equal to 1 is equal to P, in this case is 4P, if you remember. P is P of, this is also equal to PBC in the sense, and this is PAB. PAB is also equal to P steel, which is equal to 4P kilonewton. PBC, which is equal to P steel, which is equal to 2P kilonewton. Sorry, P steel, which is equal to 2P, 2P, P steel 3, which is equal to 3P. That's clear. PL is 4P, length is 600. If you want 10 power 3, write 10 power 3 by area of cross section. Sorry, I cannot use this formula. This is a tape. Sorry, I made a mistake. The formula for tapering cross section I should use tapering circular cross section, which is nothing but, can you tell me the formula? It's 4 PL by pi E d1 d2 of aluminum circular rod of tapering cross section, which is equal to 4 into P aluminum is 4P into 10 power 3 into length, it's 600 by pi into Young's modulus is given in the problem for aluminum. It's 70 GPa, 70 into 10 power 3. D1 is a small diameter, which is equal to small diameter. It's 12.5 mm. Tapering bar 40 mm, 12.5 mm. Okay, 12 1 what's 12.5 into 40 plus P steel, which is equal to 2P, which is equal to 2P 2P into 10 power 3 into length 700 PL by AE. Area of cross section is given. Give me a moment. It's 400 and 200 mm square. PL by 400 into Young's modulus 200 GPa, 200 into 10 power 3 plus P it's sorry, P it's 3P 3P into L 500 by area of cross section 200 into 200 into 200 into 10 power 3. Can you solve this? How will you solve this? Throughout your P, how will you solve this? You can solve in your calci, if you have calci, alpha. Alpha, first you press alpha, press 1, then press alpha, that solve is equal to, then you press that solve, and then you can put the equation, you can solve. Can you do that? Have you understood?
Once you
Alpha,
repeat, sir, how in
yeah,
calci?
press alpha. It's next to the left extreme end. There are two
Yes, sir.
buttons.
Yes, sir.
Alpha, press 1. Okay.
Okay, sir.
Alpha.
Okay.
Below that there is one button, right? Towards left hand side. What is it? Give me a minute. I'll take my calculator. I'll take my calculator. Wait. Do along with me. I will also be doing on press 1. Okay. Done. Done.
Yes, sir.
Okay. Next alpha solve. Press alpha and solve. We'll get equals. Right.
Yes, sir.
Then take the brackets, small brackets. Take the numerator by denominator. Okay. Type the equation. You can before that cancel out 10 power 3 throughout. Cancel it. Sorry. Okay. Next, you take 4 into 4, 4 into 4 into alpha, and then you press close bracket, small bracket, SD, the S to D, the before the left,
Yes, sir.
towards left, plus X. 4x into 600 by shift pi into 70 into 12.5 into 40. Right? This is one term. Plus, once again, open the bracket, this term 2 into alpha. Once again, this is your close bracket x into 700 by e d1 d2 by 400 into 200, close the brackets, plus same thing 3 into alpha x into 500 divided by 200 into 200. Now don't press anything. Now you have to press solve. Now you have to press solve only, not equal to. Solve. You have to press solve. Okay, solve. Solve for x. Yes. Have you made any syntax error? Give me a moment. 1 is equal to 4 into 4 into x into 5 into. You have to press x. I have made syntax error. Somewhere some brackets I have missed. You calculate and tell me. Oh, I have taken one bracket extra here. Are you getting that equation? Solve your plus. Any are you finding any difficulty? You have to you have to press shift solve. You have to press shift solve. Sorry, give me a moment.
4.8, sir.
What are you getting? Give me a moment. One is
4.8.
how much?
4.8.
4.8 ಇಲ್ವಲ್ಲಪ್ಪ ತುಂಬ ಕಮ್ಮಿ ಆಯ್ತು. P is equal to is getting 7 kilonewton. 4 PL to 2P 700. PL. Have we done? What have we done? 200 into 10 per 3. Give me a moment. Oh. Give me a moment. Okay. How much you're getting? How much you're getting? Solve that. 4 into 4 in where I have done wrong. Anybody got the answer? Or you can take one term by one term. First you can say 4 PL by pi d1 d2 you can calculate. Next PL by that you can calculate. Next you can calculate the next term. Or at test stage you can calculate everything. But give me a moment. It should come.
Sir, 7.97.
You are getting right. 7.0 7.97. Okay, 7.97.
Okay.
7.97 or 7.027 is the right answer. Is what he is getting. Okay. I am getting syntax error. I don't know why. What happened? I have done correctly, but I am getting syntax error. You are getting how much?
7.97 I got, sir.
No, 7.027.4 Newton is the right answer. I'll calculate once again. Let me calculate once again. All of you are trying. Did you got it? Yeah, I got it 7.027 kilonewton. I got previous only. I thought it's wrong. It's 7.027 kilonewton. P we're expressing in kilonewton, right? So it's P. It's P is equal to 7.027 kilonewton. Hope you have got it right. ನನಗೆ ಮೊದಲೇ ಬಂದಿತ್ತು, but I have not seen. Have you got it?
And I got, sir. Yes,
Okay,
sir.
that's it. This is how you have to solve. If there is one, this you should always mind that only one unknown can be found from this unknown x. That's it. If there are two unknowns, you cannot solve with one equation. Okay, and then you should take equation. This is about the varying cross section type of problem. Next, we'll go for indeterminate structures. I'll finish it off this. Next week, I am busy with this examination duty. If time permits, in between, I'll take the class. But you should be ready to do the assignment problems. So that's why I take the special class today, one class extra. Okay. Indeterminate structures. It means to say indeterminate structures in the sense, it means to say that the number of equations what we have is not sufficient to find the unknowns. Unknowns are the reaction forces. The number of equations what we have are not sufficient to find the unknowns, that is the reaction forces. In the previous problem, it was fixed like this. It was fixed in the one side, it was fixed, or somehow it was not at all fixed. The 10 minutes I have. Okay, we'll try to manage. Okay, something like this. Indeterminate structures in the sense, if the number of unknowns are greater than the number of equilibrium equations available, those type of problems are called as equilibrium equation. In this problem, there are two unknowns. But only the equilibrium equation, what we know for this type of problems is summation of forces in y direction is equal to 0. Previously, we were talking about the summation of forces in x direction is equal to 0. Since the forces are coming in y direction here, summation of forces in y direction is equal to 0 is the equilibrium equation. If I reschedule it for another 10 minutes, would you be able to log in for another 10 minutes or complete this problem? Right? Only cope up with only for 10 more minutes. In case if this problem does not complete with 10 minutes, L by 3, L by 3, L by 3. Okay. Now I will just assume, anyhow I want the reaction forces. I will assume RA to be like this and RB also to be like, however you want, you assume that. Okay. First, as usual, by taking the sections, I'll take the first section, like this, RA acting like this, P of AB, I write directly, P of AB is equal to RA. Next section, this is 2W. We need to find the reaction forces in this problem. This is 2W, sorry. This is 2W. This is RA. Therefore, this will be PBC. I'm directly rushing PBC. This will be my RA. Positive force is force acting upwards is positive. RA minus 2W minus PBC is equal to 0, or PBC is equal to RA minus 2W. Last part, RA 2W W PCD. RA 2W W PCD. RA minus 2W minus W minus PCD is equal to 0, or PCD is equal to 3W minus RA. Is this right? PBC is equal to PBC, PCD, sorry, PCD is equal to PC is equal to RA minus 3W. PPC is equal to RA minus 2W. PB is equal to RA. Okay. RA minus 3W. Okay. Now, see, what you should know is, what is the deformation of the entire bar? The total deformation is equal to 0. The bar cannot extend or within the total deformation. It means to say that, it means if this extends by 2 mm, it contacts by 1 mm, this also contacts by 1 mm. Therefore, total deformation of this bar is 0 only. Okay, if it contacts by 2 mm, this extends by 2 mm, this also extends by 2 mm, for example. But total deformation of this entire structure, since it is constrained at both the ends, is 0 mm. There is no deformation at all. Okay, even though deformation happens at each section, but when we take for the entire structure has 0 deformation because it is constrained at the either ends. Okay, now we'll go ahead. 0 is equal to PAB. I'll write directly P into PBC. Sorry, PAB. PAB is equal to RA. RA L by 3. L by 3. Area on the Young's modulus means GL is equal to PL by AE plus this is RA minus 2W. RA minus 2W into L by 3 AE plus RA minus 3W into L by 3 into AE, or L by 3 also cancels, or 0, which is equal to RA plus RA minus 2W Okay, plus RA minus 3W, right? RA is equal to 5W, 3RA is equal to 5W, RA is equal to 5 by 3W, right? RA is equal to 5 by 3W. See how simple we obtained the results. RA is equal to 5 by 3W. Now, after obtaining RA, we can find out this thing also, RB also. RA, I can write RA acting upwards, 5 by 3W, 5 by 3W. I'll write this. Summation of forces in y direction is equal to 0. 5 by 3W are acting upwards as we assumed. Our sign convention, the direction what we have assumed and the answer what we obtained are same. Therefore, 5 by 3W minus 2W minus W. This is acting upwards plus RB. However you want, you can take RB is equal to 0. 5 by 3W minus 3W minus 3W plus RB is equal to 0. 5 minus 5W minus 9W by 3 is equal to RB. RB is equal to minus 4W, sorry, minus 4W, 4W by 3. It means to say that my RB is not acting upwards, RB is acting downwards of magnitude 4W by 3. This is 4W by 3. This is 4W by 3. That's all, right? See how simple by assume the sections we can solve the same thing. Many problems can be solved by this convention easily. Indeterminate problems all can be solved easily. Many advantages are there in the future. Okay, any doubts in this? Any doubts in this? Any doubts?
No, sir.
Have
No,
you
sir.
understood?
No.
Have you understood?
Yes, sir.
Okay. I will give you assignments. By next week, I'll take 1 or 2 classes if possible. Okay. You should be able to complete the assignment and send it to me. Okay. Tomorrow, if possible, I will take 1 more class. And as Guru Prasad sir, right? Guru Prasad sir will be taking class at 8:30 in the morning. Your ADE class. Okay. He said that he will be taking today's class tomorrow at 8:30 in the morning. Okay. If any doubts, you can ask me. We'll complete another 2 or 3 varieties of possible. If possible, I'll schedule a time. I'll clearly inform you. We'll engage the class and we'll complete off. And then I'll be left out with that Young's modulus Poisson solution type of problems, and we'll do some derivation. It is very easy. We'll do that also in the future. Okay. Another 8 classes is sufficient for me to complete the first module. Okay. Any doubts you can ask me. You can message in the group or you can call me personally and ask me. Regarding books, I have not told you anything. I deviated it that day. For you to understand better, there is a software. I will also show you. It's before showing the software, you just watch this. Okay, there's something called as 1 minute remaining. I'll show you. You go to Google Chrome, Google, say Make Movies. Make Movies. In that you go to the first web.ms2.edu. You click on that. You enable the Adobe. Okay. See in this, for example, if you take stress, yes, with animation, he has done that. Concept checkpoints. This is very good for understanding purpose.